So we were doing something called as orthogonality relation for the Legendre's polynomial, and I have made a mistake somewhere. That's why I was not able to figure out. And since there was lack of time, so okay, sorry. So if this is differential equation, okay. So let me reiterate what I was doing. So orthogonality properties, if you have a Legendre's polynomial Pm and Pn, and if I want to integrate them from -1 to 1, Pmx, Pnx, dx from -1 to 1, it is equals to 0 if m is not equal to n. If m is equal to n, then this comes out to be 2 upon 2n plus 1. This is the Legendre's differential equations. So if the Legendre's differential equation, if Pmx and Pnx are the solutions for it, so it must satisfy this differential equation. I made a mistake somewhere, I don't know. Okay, so this should not appear. Sorry. That is what is a mistake was. Okay, so this is not going to appear because see, if I want to write it in a very compact form, what I would do, I would simply write it as 1 minus of, d by dx of 1 minus of x square, and then I will write it as y dash, and then I will write plus n into n plus 1 y. Is that clear? Because see, the derivative, if it will give you 1 minus x square y double dash minus, because see, 1 minus x square derivative is minus 2x. So this will be taken care of. So we don't need to write this. Is that clear? And I know that Pmx and Pnx are the solutions for it. So obviously this would satisfy the differential equation. Now, if you multiply the equation number 1 by Pm and equation number 2, if you multiply by Pn, this is m into n plus 1, n into n plus 1. Actually, whenever there's a lack of time, I try to write very fast and then I'm not able to recognize my own writing. This is pathetic. Okay, chalo koi nahi. Jo hai. So if I multiply the above by Pn and below by Pm, what I will get? So let us try to write that. So what I will get is, this is simply एक मिनट सोच के करते हैं. So what I'm getting is Pm is here, Pn is here. Okay, this is Pm. So एक काम करते हैं, पहले पीछे वाला पार्ट लिखते हैं m into m plus 1 minus n into n plus 1, and then I will write this as Pm into Pm, right? This is one of them, and another one of them can be to write, है ना, इसको कैसे लिखे और क्या कर सकते हैं? Am I writing all these things? ठीक है, I think it is right. घटाना ही तो होता है. हाँ ठीक है. So if I'm subtracting this, the other portion that I will get is simply Pn d by dx of 1 minus x square. I'll not write x dash x in this, and minus p कहाँ गया ये m Okay, so this is how I can write. Is that clear? I hope यहाँ तो कोई गलती नहीं कर रहा, राइट? एक काम करते हैं, लेफ्ट हैंड साइड वाले को सेकंड जो फर्स्ट पैकेट है इसको थोड़ा सा एक्सपैंड करके देखते हैं, चेक करते हैं ये क्या है क्या. लेट अस राइट इट हियर. ठीक है, लेट अस राइट इट हियर. सो व्हाट इट विल बी this is Pn, and then I will write it as 1 minus of x square, and then I have Pm dash minus 2x Pm double dash, and then I have Pm dash. Okay, and I will write it as 1 minus of x square, and then I will write Pn Pm double dash minus 2x Pn Pm dash. So this is how it is. And similarly, this will be also the same way. I'll write minus. I will write Pm. I will write 1 minus of x square, and then I will write Pn double dash. I will write Pm. Then I will write minus 2x, and I have Pm, and then I have Pn dash. Okay, and if I want to write it in a compact fashion, what I can do, I can write it as in this form, d by dx of 1 minus of x square, and then I can write Pn and sorry, I can write pn dash minus pm dash. Why I can do so? Because you see, uh, uh, see, if I don't differentiate 1 minus x square, then I'm bound to differentiate this. So this will give me 1 minus x square, and this entire stuff, मतलब ये जो अंदर वाला टर्म है, it will be like pn double dash minus pm double dash, and then you have pm dash minus pm dash, forget about it, and remaining minus 2x, and then you have pn dash, and then you have minus pm dash. So, okay, now let us try to see what all terms are matching. So this term pn dash, pm and pn dash, this is coming from here. So this is pm and pn dash, fine. So this is coming, obviously this is coming in a negative way, so I'll write a negative, don't worry about it. Okay, is that clear? So this is there, okay, with a negative sign, minus 2x pm into pn dash. So minus 2x pm into pn dash. This is negative here and this is positive here. So overall, you can say that if I replace a negative sign here, so my things would be equated. Is that clear? ये चीज समझ में आ रही है नहीं आ रही? मतलब what I want to say that this entire expression I can write it as minus d by dx of 1 minus of x square, and I can write pn dash minus pm dash. Is that clear? भरत समझ में आ रहा है यहाँ तक? कहाँ गया?
हाँ तो रहा है, थोड़ा करके देखना पड़ेगा।
हाँ मतलब तुम एक बार
डैश वाली टर्म भी है।
मैंने क्या किया, ये जो टर्म है इसको ऐसे लिखा, and then I'm trying to compactify and saying that d by dx of 1 minus x square pn dash minus pm dash. I'm arguing that this particular different derivative would eventually coincide with the above and with the negative sign. I mean, this is something that you can see, check on your own also. And I'm seeing the resemblance, so I'm not going way beyond that. So only thing that I want to say that this is something that I'm leaving for you to check. But this term here, I can write it as minus d by dx of 1 minus of x square. And then I have this term pn dash. And then I have minus pm dash. And then I have plus m into n plus 1. And then I have n into n plus 1. And then I have pm, and then I have pn equal to 0. Is that clear or not clear? ठीक है, या फिर एक काम करो, इस पूरे को उठाकर वहीं फेंक दो, सबसे आसान. So what I'll do, I'll simply take this entire stuff there. So I'll get d by dx of 1 minus of x square, and then I have pm, I have pn dash minus pn, I have pm dash, and I can write it as m into m plus 1 minus n into n plus 1. I have pm pn. Okay, so this is what I have to do. What I have to do, I will integrate on both sides from minus 1 to 1. So I'll integrate on both sides from minus 1 to plus 1. And what I'll get, I will simply get 1 minus of x square, okay? And this is pn dash minus pm dash from minus 1 to plus 1, because this is d by dx, and here you take dx, so you'll get simply m into m plus 1 minus n into n plus 1, integral from minus 1 to plus 1. This is pm, this is pn dx. Okay, and one can see that this particular thing would vanish anyhow. See, place x equal to 1, this would be 0. Place x equal to minus 1, this would be 0. So in any case, one can find, and this will be like this, one can find this integral from minus 1 to plus 1 pm dash, and there would be equal to what? It is equal to 0. It is equal to 0 because see, you can see that अच्छा, एक और चीज समझने की कि m belongs to natural and n belongs to natural here. So both of them belongs to natural. Let us try to find what is this. So I'll write it here. इसको खोल के देखते हैं. So what it will be? It will be m square minus n square. So I'll write m square minus n square, and then plus this is m minus of n. So this is m minus of n. So I'll write m minus n, and I'll write m minus n plus 1, because see, m minus n, if I take common, this will be minus 1 to plus 1, tm pn x dx equal to 0. So if m is not equal to n, so if m is equal to n, then anyway this would be 0. So if m is equal to n, ये अपने आप ही 0 हो जाएगा, not because this is 0, not because this is 0. Even if it is non-zero, if m is equal to n, in any case, this is going to become 0. So I'm taking the case of m not equals to n. So I'm using that if m is not equal to n, then what will happen? So if m is not equal to n, then one can instantly see that minus 1 to 1, because certainly m belongs to natural, n belongs to natural. This will remain a non-zero term. And if m belongs to natural and n belongs to natural, and both of them are not equal, then obviously this term will be non-zero, this term would be non-zero. It implies minus 1 to 1, pm pnx dx would be equal to what? 0. Is that clear? Is that clear or not clear? कहाँ चले गए सारे सारे? Is that clear or not clear? कहाँ
Yes
गए?
sir, yes sir, yes sir.
Okay, one thing that I want to say, that today I'm having a lack of time, so I'm not going to derive m equals to n. I'll derive that m equal to n tomorrow. But overall, have you got the gist of it? So m equal to n is a long derivation, so I'll do it tomorrow. Because if m is equal to n, then the solution should come as 2 upon 2n plus 1. And that would for that, one needs to find a reduction formula, that is integral 0 to pi by 2 cos n theta, cos 2n plus n theta, if I correctly remember. So वो करना पड़ेगा, and that is going to be another 30-minute lecture. So overall, understand the fact that you arrive at the orthogonality relation, at least to an extent, that if m is not equal to n, then what would be the solution? If m is equal to n, I'll solve it for that for you tomorrow. But meanwhile, this is what I have today, because there is a literally lack of time. So tomorrow we'll start anyhow at right time. So I'll keep my laptop charged anyway, because my laptop was not charged, so I could not start the class. Okay. And I was not aware of the power cut today. So overall, understand, is that fine? Look, tomorrow or probably day after would be the last run for Legendre's polynomial. And once we are done with Legendre's polynomial, we'll be at a convenient stage to start with multiple expansion. I hope it is clear.
Yes sir. Sir, इसमें t क्या है?
इसमें ठीक कोई भी वेरिएबल है which is less than.
तो हम लेकिन x को ही मतलब चेंज कर रहे हैं, p1 pn1 या pn-1 निकाल रहे हैं, t को हम t ही रख रहे हैं सर.
Right. तो हम लोग कर क्या रहे हैं? We want to find कि what is an associated term with t. What is an associated term with t, and we'll compare them out. T is another
Okay.
variable. Okay. So होता क्या है, अगर आप इस तरीके से एक्सप्रेशन लिखते हो, so थोड़ी सी कैलकुलेशन है, and once you do that calculation, you'll find that the binomial expansion to this would correspond to this expansion, and then you can compare those two terms. So I'm not getting into the derivation part कि ये कैसा है. Probably I am thinking to record a few lectures, but why record? Because see, these are very tricky things. तो होता क्या है इसमें, मैं अगर जल्दीबाजी में थोड़ी भी गलती करूंगा ना, then things will go wayward. So I'll try my level best to record a few of them, so that you know the derivation part also. But for physics, you're not required to remember the derivation part. Physics, you just need to remember these structures, that these structures can exist and will fall upon only when you have this conservative activity. This is quite important as a result. This is quite important. So we'll see all these things tomorrow anyway. Okay. So